In this video, we continue working towards trying to find, to assign climate to different regions using clustering and other aspects of Spark's machine learning library. We had gotten to the point where we have our latitude and longitudes and their distributions, and we have a number of other values that we need to get. So let's go through, and the next things we should grab are the average and deviation of the temperature. Turns out that I guess the code for that looks very much similar to this, except it's not on the full filtered data, because the Tmax is only in this data frame. So I'll call it Tmax data is the Tmaxes, and I will aggregate. Now in this case it's not ln, it's value, and I'm going to call it Tmax, and the standard deviation also of value, and I will call it Tmax std. The fact that the data file keeps the format in some ways is simple. It has a very small number of columns, but that causes some challenges for us, and the fact that we do have to filter down to one type of data in order to get things from that. If it had been stored where every entry had a max and a min and a precipitation, in some ways that would be easier, unless of course there were a whole bunch of nulls, and that would also complicate things. Okay, so then the Tmax would be Tmax data, and we will select out Tmax and convert it to a double and get the first. Tmax, Tmax, Tmax. Tmin is pretty much the same. Min, min, min. We want to pull this from the data frame with the mins. I'll call it min and min. Note that value doesn't change because value is the same for all values regardless of what type of data it was. It's the measure that we filtered on up here that is telling us what type. Okay, so I believe, let's go back up here. So after the latitude and longitude, we had Tmax, Tmin, and then their standard deviations. So those are the values we now have here. This should be Tmax, Tmin, Tmax std, Tmin, standard deviation. I'll go ahead and hit enter here. And now I need three more. A precip, a Tmax, seasonal var, and a Tmin, seasonal var. Okay, how do we calculate those? Well, you can probably guess the precipitation is going to look something like what we've done before, except I'm not calculating a deviation for this precipitation. My argument for that is that I don't think it's very meaningful. Turns out that most places have 0 most days, so the precipitation is going to be a very skewed value, and so I don't think that is particularly useful to us. And I will pull this from precips. We get the value out. I am going to categorize this as precip for its name. Okay. And then I can basically do exactly what I was doing here for in the next line. Select out precip as a double, and then get the first element. And that should give us our precipitation. The last two values, well, we have a method here that's supposed to calculate them. So calc seasonal var. So how about I copy this, and I'm going to say val of that equals calc seasonal var, and the data frame that I want for this one is my T maxes. I want to do the same thing for minimums, and I'll call that. And so both of these calls will go up here, and they will use the linear regression that we've already written. It'll take the small amount of data that we have for just Tmaxes or Tmins in a year and attach day of year information to it, and then come back down here and give us back a cluster data. We'll unpersist the data, and then we will give this back. Okay, looks to me like we're about ready to see if this works. All we have to do is call calc cluster data on a given value. So let's do a print line calc cluster data. We need to figure out what data frame we're using, and the cluster I'm going to start off, I'll just hard code in cluster number 0. Okay, actually I guess up here I was using cluster 441. Maybe that's an alternate one that could be interesting. But what about this data frame? What data frame should we use here? Well, it turns out that data frame needs to have information about both the clusters and the weather, and we don't have that yet. So what I'm going to do is I'm going to make a new, I'm going to call it joined data, and that name should tell you kind of how I'm going to get this here. I need to join together both my data from 2017. I need to join it with the data that we have up here, stations with clusters. Stations with clusters, and we're going to join it on the ID. Turns out we're going to use this a lot, so I'm going to go ahead and cache this whole thing. We are actually not using this. Remember, this was just the data for one particular cluster. Down here, we're going to wind up getting that, and so this won't be df, this is join data. Okay, so I want to run this. I'm actually going to make a few other changes. First, I'm going to get rid of the future. So the future is very helpful for making the plots pop up as we go through calculations, but it turns out that it kind of swallows exceptions. And so if anything goes wrong in here, having that future can make it a lot harder to tell. The other thing that I'm going to do is I'm going to go to the Run menu and Run Configurations. And so I'm on NOAA clustering. I'm going to give this a VM argument of -x mx. Let's go with 16G. Okay, so I am allowing the Java runtime to take 16 gigs of RAM. That way we shouldn't have problems with running low on RAM. So I'll run the program, and we're hoping that this prints out some information for cluster 441. And sure enough, here we have an exception. So it went through and it gave me the table, and then we get an exception here, and it says it cannot resolve the tmin. We can find the last line of code in our coding here. Okay, so tmin, indeed this did, no? Oh, it was, okay, I see a typo. Is pulling this out of max instead of min. And this is pulling this out of max instead of min. Yes, and so there's nothing called tmin because it was called tmax because it was pulling out of the wrong one. Okay. So we can take this and run it again. Save the changes so it'll build. This time it managed to complete, and we have our cluster data here for cluster 441, latitude, longitude, average high temperature, average low temperature. I thought those were the things. So that, oh wait, no. Standard deviation of latitude, standard deviation of longitude. I'm like, the low shouldn't be bigger than the high. Average high, average low. Okay, those make sense. Deviation of highs, deviation of lows, precipitation, and seasonal variations. Okay, so this appears to work for this. There are still problems with this code. So we're going to come back in the next video. We're going to run it on some other situations and basically see if we can break it so that we can add the things in so that we can do our final clustering.